just to finish off the coordinate geometry chapter and the equation of the line, I'm just going to go over the way to use the general equation of the line. So this here, y minus y1 is equal to m times x minus x1. So where does this come from and how do we use it? So if we're given a point on a line and a slope, like we have been here, we can use this general equation of a line to find the equation of a line. So the point is at minus 3, 1, so minus 3, so that's on the x-axis, and so you go left 3, so minus 3, and you go up 1, positive 1, and that point will be about here, and I'll label it P. The slope of the line is 2, so when you go across 1, you go up 2, and so again, when you go across 1, you go up 2, and you can draw a line through these points, and you'll find that this is a rough estimate of the shape of our line. And so how do we use the general formula of a line? The general formula comes from the actual fundamental, definition of slope. So slope is equal to rise over run. And how do we calculate the rise? Well, that's just the change in the y values between 2 points, right? So that's y2 minus y1. Slope is usually represented as little m. And the run is the change in the x coordinates. So that's x2 minus x1. And in this case, we know the slope, so m is equal to 2. We have 1 point, so we can use that 1 point as x1 and y1. And because we only have 1 point, we can just say that the other point, the second point, has an x coordinate of x and a y coordinate, and we just label that y. And we can use these as x2 and y2. So when we substitute these in, you have the gradient, which is 2, is equal to y2, which is just y, minus 1 divided by x2, which is just x, minus x1, which is minus 3. So I'll put that in brackets. And now, how do we simplify this equation? Well, you could leave it as this, but usually we want to simplify it and change it into a nicer form. So we can multiply both sides by this bottom, the denominator, which is x minus 3. We can multiply both sides by that to get rid of it on the right-hand side. Otherwise, you could, move it across the equal sign would be another way of doing that. So we move it across, and divided by x minus 3 will become multiplied by x minus 3. And we can simplify this, so x minus 3 is x plus 3 is equal to y minus 1. And then we can simplify this further. 2x plus 6 is equal to y minus 1. And then finally, there are two ways of writing this. You could write it in the general form, where you bring everything to the left-hand side. So 2x minus y, and then plus 7 is equal to 0. So I've brought y minus 1 to the left-hand side. Or you could write it in the form y is equal to mx plus c. So in this case, the easiest way will just to bring the minus 1 across the equal sign. So it's 2x plus 7 is equal to y. And then flip it around. So y is equal to 2x plus 7. And that will be your final answer. Another way of doing this actually would be to use the y is equal to mx plus c. So you could use the general equation of the line, or you could use y is equal to mx plus c. So we're given, I'm just going to copy down the numbers. So the point is minus 3, 1, and the slope is 2. So we know that the slope is 2, so m is equal to 2. And we know that the point is definitely on the line. So when we substitute minus 3 into the x value and 1 into y, the equation should remain equal. So we can substitute these into the y equals mx plus c form to work out the c value, right, which is the y-intercept. So when we do this, so we plug in y is equal to 1, the slope is 2, x is minus 3, and then we don't know what the y-intercept is, so we just leave it as plus c. But now we can determine what c is with some basic algebra. So 1 remains the same, minus 6 plus c, and then we bring the minus 6 to the other side, so it becomes c is equal to 7. And then, so therefore, the equation of the line is y is equal to, the slope is 2x plus 7, because we just figured that out. Now, if we have 2 points, if we know 2 points on the line, we can also use the general formula, which is y minus y1 is equal to mx minus x1. We're going to also use this, but we need to first determine the slope, right? Because if we're given 2 points, we don't know the slope straight away, but we can definitely figure it out. So in this example, we're given the 2 points, let's just call them A and B. So A is minus 2, 3, and B is 3, 1. So first we can determine the slope. So what is slope? Slope is rise over run. And the rise is just a change in y values. So y2 minus y1. Slope represented by little m. And the run, the change in x values, x2 minus x1. And then simply, we can simply substitute these values in. So I'm just going to write down what each of the variables are. So the slope is equal to y2, which is 1, minus y1, which is 3, divided by x2, which is 3, minus x1, which is minus 2. And so when we simplify this, it will be minus 2 divided by 5, which is equal to minus 2 over 5. And that is our slope. And so what next? So we have the slope. Now we can use the general formula for the line. So y minus y1 is equal to mx minus x1. We choose one of the points to use because we only need 1 point in this general formula. So I'm going to choose A. So let's say y minus y1, which is 3, is equal to m. And because we just determined m right here, we can plug that straight in. And then x minus x1, and x1 is minus 2. Don't forget the negative 2, the negative sign. And then now we can simplify this. Now I don't like fractions, so I'm going to multiply everything by 5. So that would be 5y minus 15, and that gets rid of the fraction here. So I've just multiplied both sides by 5. That gets rid of the fraction, so it just becomes minus 2x plus 2. And now you can simplify, so minus 2x, this is minus 4, and then this remains 5y minus 15. And now we can either express it as the general form, so move everything off to the left and make it all equal to 0. So this would look like this. So you bring the minus 2x and the minus 4 across the equal sign, so they become plus 2x, so 5y plus 2x, and minus 4 becomes plus 4. So that'll be minus 11. And this would be your equation of the line containing the points containing these 2 points here. Or else you can express it in the form y is equal to mx plus c. And how would you do that? So you would need to bring the minus 15 to the right hand side and divide the whole thing by 5. So let's do that. So 5y is equal to minus 2x. Minus 15 becomes plus 15. So it would be plus 11. And then divide the whole thing by 5. That would be minus 2 over 5x plus 11 over 5. And you can leave these as the fractions, the simplest fraction. And this would be another way of expressing that same line. Here is another problem to do with the equation of the line, but now we're starting to involve other components of coordinate geometry. So we're adding in perpendicular and parallel lines. And a quick revision, parallel lines never touch. And so parallel lines in coordinate geometry have the same slope. So the slope of the line A is equal to the slope of the line B. Perpendicular lines, on the other hand, meet at 90 degrees, so something like this. And their slopes, their slopes multiply. So I'm going to call this line C and line D. If these two lines are perpendicular, their slopes will multiply to give you -1. And so if we know the slope of line C, then you would just do the negative reciprocal. So basically change the sign and flip the fraction around to get the slope of line D. And so the question asks us, find the equation of the line through the point minus 2, 3. So let's quickly draw that on a graph. So the point minus 2, 3 would be, I'm going to draw the x-axis a bit smaller. The point minus 2, 3 would be around here, minus 2, 3. And which is perpendicular to the line 2x minus y plus 5 is equal to 0. So this isn't going to be very accurate, but I'm just going to roughly do something like this and this. So this line here that I've highlighted in green refers to this line, the green line on the graph. And that green line is perpendicular to the black line, which is the line which we're trying to find the equation of, which contains this point P. Okay, so make sure you got this rough image in your head of what we're trying to do. So we know the equation of the green line, but we're trying to find the equation of the black line, which is perpendicular to the green line and passes through P, which is this point here, minus 2, 3. Okay, so first of all, we know one point on the black line, but we don't have the slope of the black line. So we can't use the general equation of the line yet. So we first need to work out the slope of the black line. So how do we know that? Well, we know the green line is perpendicular to the black line. So we can find the slope of the green line. And how do we do that, you may ask? Well, there are a few different ways, but the easiest is just to express this green line, the equation of the green line, in the form y is equal to mx plus c. And the easiest way of doing that is just to move the minus y across the equal sign, so it become plus y. So now you have y is equal to 2x plus 5. And from this, we know that the x coefficient is equal to the slope, right? So the slope of the green line, which I'm going to label as g, is equal to 2. And so if the black line is perpendicular to the green line, we take the negative reciprocal. So this is the slope of the black line now. The negative reciprocal, so you flip 2 around, it'll become a half, right? Because it's 2 over 1. When you flip it around, it'll be 1 over 2. And you change the sign, so it'll become negative a half. Now we have the slope of the black line, and we have a point. So now we can use our general formula y minus y1 is equal to mx minus x1. So y minus y1 is, y1 is 3, is equal to m, which is the slope, and that's this slope here, right? The slope of the black line is a minus a half times x minus x1, which is negative 2. Make sure all the signs are correct, so negative 2 minus minus 2. And now you can simplify. So you can multiply this side out, so it'll be minus half x. Minus minus 2 is the same as plus 2. So minus a half multiplied by plus 2 is equal to negative 1. And then y minus 3 stays the same. And now you can move the minus 3 on the other side, so it becomes plus 3. So you'll just get plus 2. And because this is in the form y is equal to mx plus c, you can leave it in this form, and that would be your final answer. Of course, you can also leave this in the general form, which looks something like this. So from this step, you could move everything on the right hand side over to the left hand side. So minus a half x would become positive a half x plus y, and then minus 1 will become plus 1. So that would be minus 2 is equal to 0. And one more thing is you want all the numbers in front of the x and y coefficients to be positive, whole numbers. Sorry, not positive numbers, just whole numbers. You want these to be whole numbers. So you multiply the whole thing by 2. So you'll just be left with x plus 2y minus 4 is equal to 0. There are several different ways of drawing and graphing lines, but the very, very basic are that to draw a linear equation, you need to know at least 2 points on the line, right? So it's no good knowing just 1 point, you need at least 2 points. So the very, very easiest way, if you're stuck with trying to figure out the slope or the intercept or the x and y intercepts of a line, you can always just use, let's say, for this line here, 2x plus 3y is equal to 6. You can always just create a table of x and y values. So let's say you substitute in x is 1, x is 2, x is 3. So when x is equal to 1, so in this case, if x is equal to 1, that will be, let me just put in a little middle step here. So when x is equal to 1, that would be 2 times 1 plus 3y is equal to 6. And you would solve this. So you would bring the 2 to the right hand side. So plus 2 becomes negative 2. So 3y is equal to 4. So y is equal to 4 over 3. Then you can substitute in 2 for x. So you do the same thing. You bring the 4 across. So 6 minus 4 is 2. And then 2 divided by 3 is 2/3. And then you do the same for 3. 6 minus 6 is 0. 0 divided by 3 is 0. And then you see you have a few points. You would plot those points on a graph and draw a straight line through them. So that is the simplest way if you're stuck. Just substitute in x is equal to 1, 2, and 3. What else can we do though? Well, we can also use the y is equal to mx plus c form. Y is equal to mx plus c. The m, remember, means the slope, and the c is the y-intercept, right? So for in this same example, so 2x plus 3y is equal to 6. If we rearrange this to look like this, minus 2x plus 6, and then divide everything by 3 plus 2. We know that minus 2/3 is the slope. Maybe I'll do it in green. This is the slope, and the plus 2 is the c part, which is the y-intercept. So on a graph, it would look something like this. So if you have graph paper, this will be more accurate. but you just have to bear with me here. But we'll just get a general idea of what this line looks like. So the y-intercept would have the coordinates 0, 2, right? Because every point on the y-intercept will have a x-coordinate of 0. So you have the y-intercept, which will be approximately here. And then the slope of this line is equal to minus 2/3. And what does that mean? Well, slope means rise over run. So this basically means every time you go across 3, you will go down by 2, right? Because it's a negative 2. It's a negative slope. So every time you go across by 3, so roughly this is 3, you will go down by 2. So this will be a point on your line, right? And then you would do the same thing. So you go, I'm going to just change this over here. So this is value of 2. So every time you go across by 3, you go down 2, right? And then you would do the same here. So you go across by 3 and you would go down 2, right? And so you can just do this for once. So when you do this once, you're going to have 2 points. And when you have 2 points, you can just use a ruler and go straight through those 2 points. And then you will have the equation, then you will have a graph of the line. So that's the slope-intercept method. Another method is to determine the x and y intercepts. This is also quite easy. It's as easiest here, but the slope-intercept method is also very handy. So the first method I showed you. This is another method. So if we take the same line again, so 2x plus 3y is equal to 6, rather than figuring out the slope of the line and the y-intercept using the y is equal to mx plus c, we can simply use the fact that when the line intercepts the y-axis, so the y-intercepts, we know the x value is going to be 0, right? Because you don't go across by anything. You're always going to, the x value is always going to be 0 at the y-axis. And similarly for the x-axis, because you're not going up or down by anything, the y value is always going to be equal to 0. So when we have these, we can simply substitute x is equal to 0 into this equation, right? So 2 times 0 plus 3y is equal to 6. And then if we solve this equation, we can solve the equation for the y-coordinate, and then we will know where this line intercepts the y-axis. So 3y is equal to 6, and then y is equal to 2. So the y-intercept is 0, 2. What about the x-intercept? The x-intercept, the y-coordinate is always equal to 0 by definition. So we can also substitute this into the equation. So when we substitute y is equal to 0, we get that 3 times 0 is 0. So we just get that 2x is equal to 6 and x is equal to 3. And so we know that the x-intercept is 3, 0. And so when we graph this out, it's the same line as before. So we can also compare it to the one before to see how accurate my drawings are. So the y-intercept is 0, 2. So approximately here, 0, 2. And the x-intercept is 0, 3, 0. So you go across by 3. And using the units, that will be about here. So you have 2 points. And when you have 2 points, you simply use a ruler and draw a straight line through it. And you see that it is very similar to the one above. Finally, to verify if a point is on a given line, we can simply substitute the coordinates of that point into the equation of the line, and if it satisfies the equation, so if it works, then the point is on the line, and if it doesn't work, the point is not on the line. So let's investigate this point here. The p is 3 minus 2, whether it's on the line x plus 2y plus 1 is equal to 0. So we simply substitute 3 in for the x value. So 3 plus 2y, so the y value is minus 2, plus 1. And then, so we can simplify this. So 3, this will be minus 4 plus 1. That would be equal to, so 3 minus 4 is minus 1, minus 1 plus 1 is equal to 0. And you can see that the right-hand side is also equal to 0. So the left-hand side is equal to the right-hand side. So the equation is satisfied by this point. And therefore, the point P, 3 minus 2, is on the line x plus 2y plus 1 is equal to 0. What about a point that's not on the line? So I'm going to choose a random point. So let's say the point Q is 5, 6. And so when we substitute these coordinates into the equation, then it shouldn't work, right? Yeah. Let's try. So if the x coordinate is 5 plus 2y, the y coordinate is 6 in this case, plus 1. So 5 plus 12 plus 1, and you can see straight away that that definitely does not equal to 0. That is equal to 18, and the right hand side is equal to 0. So these values are not the same, right? They're not equal. So the left hand side is not equal to the right hand side. Therefore, Q is not on the line.